Thing I want you guys to all do right now is practice in your calculator. So here's problem number 1. I want you just to evaluate this for me in the calculator. Okay, evaluate that in the calculator for me. Go ahead and try that. Feeling pretty good? So everyone should have had 13, then go over to math, then go over to probability, and we want option number 3, and we want 10, choose 7, and we get an answer of 1,716. Oh, sorry, 13, choose 7. Did I say 10? Sorry. Yeah, 13, choose 7. I got 1,716. You guys get the same thing? Yeah. All right, sweet. Okay. So I got, this was 1,716. So just make sure you do that part in your calculator. Okay?
So it's option 3, you said?
Yeah, buddy, over here. So I go 10, or did 13, sorry. Go to math, go over to PRB, option number 3, and then put in the second digit, which is 7, push enter, and that's how you do it. Okay, second type of problem is a basic one, so I want us to be able to expand, alright, by using the binomial theorem. I want us to expand x plus 3 all to the 4th. Okay, this is a very typical first level type of question for the binomial theorem. Expand x plus 3 to the 4th. Alright, how many terms are we going to have in the expansion of x plus 3 to the 4th? Just shout it out. What are we going to have? We're going to have 5. Nice job, everybody. 1, 2, 3, 4, and 5. I'm going to label them for you. A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. And what are we doing to these terms? Are we adding, subtracting, multiplying, or dividing the terms? We're adding the terms up, right? So the expansion is addition, right? So we're adding all these terms up. Okay. Then I start with my binomial coefficients, which we find using the formula that we did in example number 1. So I'm going to start with 4, choose 0. Why am I picking 4 again? Because that's my exponent, right? And then I start and I just go all the way up. 4, choose 1, 4, choose 2, 4, choose 3, and 4, choose 4. Fair enough? Everybody go with me? Okay, next thing I want to do is I want to take the first term of my binomial, which is x, and I'm going to raise it to the power of 4, the highest power that I have. And I'm going to go down by 1 integer exponent until I reach 0. So that's x to the 3rd, x squared, x to the 1st, and then finally x to the 0. Who's still with me? Hands up, let me see. Everybody still with me? Alright, cool. Next thing, I take my second term of my binomial, which in this case is the number 3, and I do what to it?
0.
Exactly. I go the opposite direction. 3 to the 0, 3 to the 1st, 3 squared, 3 to the 3rd, and finally 3 to the 4th. Okay? Everything that we just did is the binomial theorem. Alright? It's got all these layers to it, but that's exactly what it is right there. That's the binomial theorem. So that's what I call the setup phase. Alright? Now we just got to go and clean it up, right? What's the value of 4 choose 0? It's worth 1. What's the value of 4 choose 1? It's a value of 4. What's the value of 4 choose 4? Oh, sorry, excuse me, 4 choose 2. 6, very good. What's the value of 4 choose 3? Also 4, and then 4 choose 4 is 1. So we know that ahead of time from doing Pascal's triangle. If you didn't know that ahead of time, how could you figure it out? Plug it into the calculator. Alright, good. Awesome. So let's go ahead and clean everything up. My very first term looks to me like 1 times x to the 4th times 3 to the 0. Well, that's just simply x to the 4th. You guys follow? So a sub 1 now is completely cleaned up. Second term is going to be 4 times x to the 3rd times 3. So how much is that total? That's 12x to the 3rd. Okay, did we guys see that real quick there? Did you guys see what I did? I multiplied 4 times the 3. That gives me my 12. And then I just have an x to the 3rd left over. You guys follow? Okay, good. So that one's all done. Let's go to the third term. I got 6 times x squared times 9. 54. There you go. 54x squared. Awesome. That one's done. My fourth term, I have 4 times x times 3 to the 3rd. 3 to the 3rd is 27, right? 4 27s is 108. Very good. So I have 108x. And then finally, I just have a 3 to the 4th, which is how much? 81. And you know what? We're done, and that's the whole problem start to finish. What do you guys think? Pretty good? Okay, let me show you something over here. Let's check it and make sure we did it right. So we had x plus 3 all raised to the 4th power, right? So I want to expand that. Check it out. Boom. The calculator does it for me in 2 seconds. Awesome. We did it right.
Wait, you can do that on your
I can. You guys can. This is a program called Fluid Math. Just want you guys to see that we did it right. So now we know how the calculator is doing that, right? All right. Sweet. So So that is that type of problem. Okay, so let's look at this one. This is 2x plus y to the third. Why is this different than the other one before? Who sees it? There's a 2. There's a 2. We have to be very careful with that 2, okay? Let's start the normal way. How many terms am I going to have? I'm going to have 4 terms, so give yourself room for success. 1, 2, 3, and 4, and label them. Here's the first term, here's the second term, here's the third term, and here's the fourth term. So far, so good. What are we doing to all these terms? We're adding them up. We're adding them up. That's what we're doing to all these terms. Put a plus sign. All right, now I'm going to start with my binomial coefficient. You've seen this show before, right? 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. So far, so good? Good. I'm going to take my first term now. I'm going to do this in green. My first term of my binomial is 2x. So I need to keep that 2x together the entire time I'm raising it to the exponents, okay? What I mean by that is I'm going to have 2x all to the what power, you guys? Third. Then I'm going to have 2x all to the what power? Second. And you guys kind of get the show here, right? 2x to the first, then finally 2x to the 0. What do you think the most common mistake is that students make? They just leave 2x cubed as 2x cubed. They don't change it to 8x cubed. That's the biggest mistake that people make, okay? Guaranteed there's going to be one person in all of my classes that does it. Your goal is to not be that person, okay? Don't be that person, okay? Explain it again?
Yeah, you have to cube the 2.
Yeah, okay. All of this needs to be cubed, not just 2x cubed. We'll see you in the cleanup phase, okay?
Is this the warning in the video?
Yes, this is one of the warnings in the video. Very good. Way to make a connection. Okay, and then I'm going to take my y, my second term of my binomial. This is pretty straightforward. Y to the 0, y to the first, y squared, y to the third. So far, so good. Everyone's pretty good. All right, now we clean it up. We know that 3 choose 0 is the value of 1. We know that 3 choose 1 is a value of 3. We know that 3 choose 2 is a value of also 3. Very good. And we know that 3 choose 3 is a value of 1. So you can go ahead and do those ahead of time if you know them from Pascal's triangle, or you can simply use your calculator. Choice is yours. Okay? Now that we have all this, let's clean all this stuff up here. I'm going to do this in blue. So 2x cubed is a value of 8x cubed times 1 times 1. So this is just 8x cubed, and my whole first term is now done. You guys follow? Okay, good. Let's do 2x all squared. How much is that? 4x squared multiplied by 3 is 12x squared multiplied by y is just 12x squared y. That's all it looks like. Is this making sense to you guys now? Good, awesome. The third term is going to be 2x to the first is just 2x. So this is a pretty simple one. It's 3 times 2x is how much? 6xy squared. And then what's the last term going to be? Everybody help me out. Y cubed. And so we think that this is the answer. We're going to check that real quick. Check this out. This is the one that we did. 8x cubed, 12x squared y, 6xy squared, and a y cubed. Yep, that looks good to me, right? Whoops. Food math is rad, man. Okay. Okay, let's go back over here. Okay, another warning comes with this binomial expansion. What's the difference between this one? There's a subtraction sign. Who knows what the trick is? Miles, what is it? They're going to alternate signs. Good, exactly. So how many terms am I going to have? 1, 2, 3, 4, 5, and then 6. Okay? The first term will be, I'll label these for you. A1, A2, A3, A4, A5, and A6. The first term will be positive. And then they will alternate signs. Minus, positive, minus, positive, minus. First term is always positive. Well, if this term is positive, right? And I'm raising it to an odd number, so I'm good to go. Positive, right? No matter what. So the ones I'm going to give you, quiz you on, are going to be just like this. So the signs are going to alternate. And that's it. Once you've taken care of the signs, like we've done here, you do not need to worry about signs anymore. It's all good and done, okay? So, again, you've seen this show before, right? 5 choose 0, 5 choose 1, 5 choose 2, 5 choose, that's a 3, sorry guys. It's a minus, 5 choose 3, 5 choose 4, and finally a 5 choose 5, okay? Our first term is x, so that's x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and then finally x to the 0. I'm going to shrink this down a little bit so I have more room. And then finally in pink, we're going to do 2 to the 0. Can you guys see the pink at all? Yeah. 2 to the 0, right? 2 to the first, 2 squared, 2 to the third, 2 to the fourth, and then finally 2 to the fifth. Notice I don't need to worry about signs, okay? I don't need to worry about signs. All right, could you guys clean this up if you had to? Okay, I don't want to waste our time with that, but I do want to give you the answer in case you want to check at home. So we did x minus 2 to the fifth, right? If I ask the computer for that, you should get that response. And notice that the signs go positive, negative, positive, negative, positive, negative. So if you want to check this one out at home on your own, at least the answer will be in the video for you. Okay, so check this out. This is a different type of question. Let's say I give you some binomial, like I have here, x plus 2y all to the sixth, and I just want to know the third term. Now we could do the whole thing start to finish and then just circle the third term and be done. But there is a way to build these individual terms that I'm going to show you right now. I did put this one in the video, I think. You guys, was this in the homework? Okay. So check this out. Here's how we build it. I am interested in a sub what? 3. I'm interested in the third term. Right? That's what I want. I know that there will be some binomial coefficient. I know I will have my first term, which is x, raised to some power. I don't know what it is yet. And I know I will have my second term, which is 2y, also raised to some power. I just don't know what it is yet. Are you guys with me so far?
Yes.
Okay, awesome. Well, there's a couple things I can fill in. I know that my binomial coefficient has to be a 6 on top. I know that. Why do I know that? Because they're all 6's, right? Because the exponent is 6, all right? Let's go back up to this example here. Let's just take a look at this one for a moment, okay? Notice that this term, right? Do you notice that what's the sum of the exponents of the terms? 4. Do you notice that that's exactly the same thing as the top number? Okay. You also notice that this bottom number down here matches the second term's exponent, right? So those have to match, right? And what's the relationship between this term and that exponent right there? Always one less. Shenanigans. Okay. So it must be true then that if I'm at the third term, that this exponent must be 2. Is that true?
Yes.
Is that what we're talking about? Okay. Now once I know that one, can I fill in the other gaps? I sure can, because I know that this exponent plus this exponent have to add to what? So that has to be a 4, and that's got to be a 2 down there. You guys with me? How sick is that? So look, we can just create any term that we want, right? Okay, so 6 choose 2 in my calculator. This is a value of 60. I went ahead and figured that out. No, wait, it's not 60. Excuse me, it's 15. Yeah, the answer, right? Then I have x to the fourth. That's just x to the fourth. And then 2 to the fourth is, 2 squared is the number 4, sorry. So I'm going to have 15 times x to the fourth times 4y squared, and then I'm all said and done, I get, gosh, I can't write, 60, come on, Dero, x to the fourth y squared. And that is my third term. So check this out. When I go over here to this one, x plus 2y all to the sixth, if I am interested in the third term, 1, 2, 3, hey look, there it is. Can you guys, oh, I've just totally blotched it out. That's amazing. My bad, guys. There we go. So 60 x to the fourth y squared. Did we do it right? Yep. We did it right. Okay. Okay, last type of problem that I want you to understand from section 10.5. Here's a more challenging one. We've given x squared plus y all raised to the 22nd power. And I just want the 8th term. It'd be very mean of me to be like, expand that thing. Because how many terms would there be? 23 terms. You guys would hate me, and that would not be fun. I just want one term. I want the 8th term. So, help me build it. Help me build it. I'm interested in a sub 8, right? I know I'm going to have a binomial coefficient. I know I'm going to have my first term of binomial, which is x squared, raised to some power. I'm just not sure what it is yet. And I know I'm going to have my other term in my binomial, y, raised to some power. I'm just not sure what it's going to be yet. Okay? I know that this number is always 1 bigger than the second term. So what does that exponent have to be? It's got to be a 7. And I know that this is going to be 22 choose that same number. Those all have to match. So therefore, what does that leave left over for the other exponent have to be? It's got to be a 15. See how cool and easy that is, you guys? Okay? If we clean this up, we use our calculator and we say 22 choose 7 is a value of 170,544. Yikes. And then when I raise a power to a power, I multiply those two, so I'm going to get x to the 30th. So the answer I'm looking at is equal to 170,544 x to the 30th, y to the 7th, and that took us, because I'm multiplying x squared to the 15th, and I multiply power to power. Let's just go ahead and check that real quick. Go over to fluid math. Let's get some help here. Okay, I'm interested in which term? Holy cow. I just wanted the 8th one, right? So 1, 2, 3, 4, 5, 6, 7. Hey! Hey! Did we get it right? Yeah, we sure did. How cool is that? Money. Okay.